Hey guys, what's up? Welcome to TSK Tutorials, and this is FPS 1.35. So in our last episode, we made a script so that the enemy could basically read the map that we made in 2 episodes ago, so that it could decide what the best route would be to take to find the player. So now what we're actually going to do, now that we know the best route to take to find the player, is we're actually going to move towards that route. So today's episode is going to be pretty short, because pretty much the only thing we're going to be doing is testing to make sure there is a goal door, because goal door was our ultimate variable goal that we got in our last episode. So we're going to be taking the goal door, which is the door that the enemy wants to go to in order to go through the least number of doors to get to the player. So we're just going to be moving straight towards that if we are not inside, or if the enemy is not inside of the same cell as the player. But if it is inside the same cell as the player, it's just going to move straight at the player. So basically what we're going to have by the end of this episode is an enemy, which is a red sphere, that can follow you anywhere throughout this maze that we created without getting lost, and no matter what, it will just walk straight towards the player. Alright, so we're going to be starting off where we left off in our last episode, which is the enemy movement script. So we're only adding one variable to it, which is current move speed. So the reason why I did it current move speed is because it's going to be easier to start it off as current move speed now, as opposed to change it from move speed to current move speed later. Because in, let's see, 2 episodes from now, I'm going to be making it so the speed of the enemy will change and increase and decrease just to simulate a congestion of enemies through a narrow hallway. So if it is a narrow hallway and there's a bunch of them, naturally in real life, these enemies are going to kind of have to squeeze into this area. So it's going to be a combination of the crowd simulation and just making them congest in hallways in a realistic way. So we're going to leave it as current move speed for now, but basically for now in this episode, current move speed is just going to be how fast the enemy moves. Alright, and the only actual script that we're going to be adding inside of function update is these couple of lines here. Alright, so out of all the script that we're going to be adding, let's first take a look at these few lines. So what I have highlighted on the screen right here basically is just going to be in place if you have the animated doors that I have from this tutorial set in your game. So the way this is going to work is if goal door, so if we have a door that has been found that is the shortest path to get to the player, then we are going to run this next if statement. And if that is if goalDoor.getComponent AI path door, so we're accessing the script that is attached to that door, and we're pulling out the variable door open. So I'm going to show you how to set up the variable door open inside of the AI path door script. But basically we're just going to synchronize that with any given animated door. So that's a door that you can actually walk up to and press E and it will physically open, that kind of door. We're going to be able to make it so that the variable door open synchronizes with that door, so that we can test whether or not there is a door open or shut that is in the way of this door, or the AI path cell door. So basically if that door is closed, so if door open, as we can see by the exclamation mark, is false, then we're going to do goal door equal null, just showing that there is no door. So the enemy is just going to treat it as if it was just a wall and there's just going to be no door there. So that's just going to stop the enemies from just plain old just walking through physical objects such as doors, or I mean in this case doors. So if in your game you don't actually have any physical animated opening and closing doors, you decide to skip that part for any reason, you can go ahead and just completely leave this out, just go ahead and delete it. You don't need that in there. So now let's move on to this chunk here. Alright, so what this line of code is going to do is basically move the enemy in a straight path straight towards the door that it wants to go to, or the goal door. But let's take a look at the if statement that is going to allow that, and that is simply if goal door and current cell does not equal player cell. So remember, if the enemy is inside of the same cell as the player, That means anywhere from the enemy's position, they can go straight towards the player without hitting any walls. But if we are not inside of the same cell, then we're going to have to go through a door in order to get to that same cell. Then we can move straight at the player. So we're going to do if goal door. First of all, we have to check to make sure we do have a goal that we want to get to. And then if current cell does not equal player cell. So if the enemy is somewhere else in the level and it has to navigate through all the walls and stuff, then this line of code is going to be run, which is very basically going to move the enemy straight towards that goal that it wants to go to. Alright, so in order to just very easily make the enemy move in a very straight line towards its goal, we're going to do transform.position plus equal goal door.transform.position minus transform.position.normalized times current move speed times time.delta time. Okay, so let's break that down. So we're adding to the position that our enemy is currently at. And then we have inside of parentheses here, goal door.transform.position minus transform.position. So we're minusing the position of from where the goal door is, and when you do that, essentially what you're doing is you're turning transform.position into 0.000, and then goal door relative to that. So now we basically have a vector 3 that represents a straight line that goes straight towards the goal door. And then when we write dot normalized after that, we're getting a magnitude vector that is pointing straight at where we want it to go. But then it is also only has a magnitude of 1 or a value of 1. So then it is more easy to manipulate. And the first thing we're going to do is multiply it by current move speed so we can change how fast the enemy moves. And then we're going to multiply it by time.delta time so that how fast the enemy moves is dependent on actual time and not the number of frames a second the computer is running at. Alright, so now basically we're going to do the exact same thing, but if player cell equals current cell. So basically, if we are inside of the same cell as the player, we know that we can move straight at that player without hitting any walls. So we're going to do almost the exact same equation as we have up here, but instead of using goal door.transform.position, we're using player transform.position. So this is going to work exactly the same, these two lines. But the only difference is that player transform.position is a moving target. So basically this whole equation is just going to adjust accordingly and just continue to move straight at the player no matter where it is. So yeah, that's all the code that we're going to be going over today. So now I'm going to cut the green screen and go into Unity and show you how to do that inside of Unity. Alright, here we are inside of Unity, and now let's take a look at where we left off last time. So what we want to do is select this enemy guy here, actually this guy right here, enemy, and I'm going to move our player throughout the level a little bit, just to give you a quick demonstration of the code that we made in the last episode. So first of all, I enter here, and now where can we go? Alright, goal door, AI path door. We can see the enemy has chose to move towards this door because my player is here, and it would not make sense to move to this door here because that is moving away from the player. This door gives us the shortest path to get to the player. So now let me show you if I walk on the other side of him. Whoops, okay. And now my player is now more over here. I'm going to click on AI path door and then see what door that is in the level, and that is this door. So it is now chosen to move towards this door because the player is now over here. So now let's add the script to make the enemy actually move towards those doors. And so we need to edit the enemy movement script, and I'm going to full screen this, and we just want to add the variable current move speed. And let's have this equal, I don't know, 5. And I think we're just adding lines of code in here. Alright, so first of all, let's start with the door stuff. So AI path door. Alright, we do have the variable door open, and it's by default set to true. So we need to open up the door script, which is this kind of door here that you can actually walk up to and physically open. So here's the door script, so let's open that up. And we have the variable open right here that is automatically going to change between true and false depending on whether or not that door is open. So we're going to go to the door script. And did we already set this up? I don't think we did. Okay. So we want to, did we add it yet? Door, I don't think we added the variable yet. Okay, well, let's add it now. Animated. Is that how you spell it? Yeah. Door. And let's make this a game object. So this variable is going to, so let's say I wanted to, let's actually physically move this door. Alright, where is the button on this one? Okay, is it physically on the door? No, it's not. Okay, so I'm going to make it physically on the door. So I'm going to drag and drop that there. And then I'm going to, what did I just move? Did I move the right thing? Yeah, the button. Oh, okay, I just had it in front of a model. Okay. So I'm going to move this in front of the door. Make it a very generic door. Okay, there we go. And now I'm just going to move this whole thing over here and have it block that door there. So let me focus in on that. Alright, so it's pretty ugly looking, but that should show us generally how the doors work. I'm going to try to space it right between the two cells. Alright, so that should be good enough. So the way we're going to do this is we're going to click on this door here that is intersecting with the door that we want the animated door to represent. And where it says animated door, we want to drop the door object there. So now we have this door object saved, the one that is right next to it. So let's save that and let's go back into MonoDevelop so that we can add in the code, which I will just throw in right here. And we're going to simply have that if animated door door open equal animated door dot get components door script, there it is, dot open. And I think that's all we need. Yeah, that's all we need. So basically, if we do assign a door, an animated physical door to this AI path door, then it will synchronize its variable door open with this door. And let me go over to my script over here. So that's what this little bit of code here is for. I'm just going to copy and paste that out of laziness, and I'm going to put it inside of the enemy movement script right there. Clean that up. Alright, so if we do have a goal door that we want to go to, so we don't want to try to access information from the goal door if there is no goal door there. So that is why we have the if statement, if goal door. So if goal door dot get component AI path door dot door open. So remember, we have this variable, we just synchronized it with the animated door. So if that is false, so if it's not open, it's closed, then we're just going to set goal door to null and pretend like there is no door there and just continue on normally. And this is going to prevent the enemies from just walking through walls. Alright. So next, what do we need? If goal door, and so I'm going to copy that. I'm just going to explain it inside of MonoDevelop. Okay, Control V. AI path door. I need the word script here, don't I? See if that got rid of my error. Yep, it did. Okay, cool. Alright. So the two lines I just copy and pasted are right here. And if goal door, so if we have a goal door that we want the enemy to move towards, and current cell does not equal player cell, so if the enemy is somewhere else in the level, then we are going to run this line of code here, which is transform.position plus equals. So we're moving the position of the transform of the enemy we're adding all of this to it. So we have in parentheses here, if goaldoor dot transform dot position minus equal transform dot position. So what we're doing is we're taking the position of the goal door that we want to get to, and we are subtracting transform dot position. So essentially we're turning transform dot position into 0, 0, 0, and we're looking at where this variable is relative to that, and that's what we get inside of these parentheses here. And then when we write dot normalized, we're setting it to a magnitude of 1, so that then we can multiply it by current move speed times time dot delta time. So we're moving at the speed that we want the enemy to move according to actual time and not just the frame rate of the computer. And now the next two lines of code that I'm going to copy and paste are going to be extremely similar to that. So copy, paste. Alright, so if player cell equals current cell, so if the player and the enemy are inside of the same cell, the enemy can just move straight for the player, no problems. So we're going to do transform.position plus equals, and we're just going to have the exact same thing as we have up here, but instead of doing goal door, we're doing player transform, so we're following the player. So why don't we go into Unity and give that a run and see how it works. I have a compiler error. Player transform. Did we not set up the variable player transform? We have player movement script, but we don't have player transform yet. Okay, so let's add that. Player transform. We're going to set it to type transform. Transform. Okay. And right here we're going to do player transform equal game object dot find with, dang it, with tag. Could have copied and pasted the line above me, but oh well. Player dot transform. Missed an S. Okay, there we go. Now let's see if we have any errors. I spelled this wrong. M-E. Okay, once again, now do we have any errors? No, we don't. Okay, now let's give it a run. Alright, so the enemy shouldn't come at me until I actually open this door, or until it's in the room that it wants to be in before that door blocks its way. So now if I open the door, now the enemy's coming at me, and he's inside of the same cell as me, so he's moving straight at me, and he hit me. And I'm gonna run around the corner, and I'm gonna try to confuse him. He totally won't find me here, no way. Wait, oh, he's finding me. Yep, that's surprising, the code works. And he just found me. Okay, he moved through a wall a little bit, so that we can fix by moving this outwards a little bit. That'll help with that. But also later on we're going to be adding more code to make that an even smoother motion. But yeah, it looks like all of our code is working and it is actually following us. So if we want, we can just lock him in here. Ha! So now he can't get to us. And now he can. So this is the very basic movements of how the enemy is going to work, except for he just stopped working. You know what I think it is I moved, yep, that's exactly what happened. I moved this over too far and it wasn't intersecting with both of the green cells. I think I moved it to like there. Let's see exactly where I moved it. Yep, it was way too far over. So I need to move it more like there. And this one I'm going to do the same. It just needs to intersect with both of the cells. So now let's give it a run. Seems to be working pretty well now. The enemy should follow us wherever we go. Where is he? There he is. Yep. He is definitely following us wherever we go. Alright, so this has been ETSki Tutorials FPS 1.35. In our next episode, we will be... What are we doing in our next episode? 36. Oh, we are randomizing the path of the player. So we're going to make the path that the enemy takes a little bit more random, so that the enemies don't quite run into each other when there's multiples of them quite as much. I don't know what just happened. Okay. Well, once again, this system is not done, and it's very basic. Alright, well, till my next episode, I'll see you guys later, and keep making games.